Hi guys, welcome to our next to last lesson on solving special systems, day 2. You're almost done. Just the same old reminders and announcements. Email me if you have questions. I'll still take anything for quarter 3 or quarter 4. If you don't have your pencil or paper out, make sure you go get some of that now. Make sure you're logged into your school email address. And if you get in the middle of the IP and are struggling, there's never a reason to guess, leave blanks, or write IDK. Just email me or attend office hours to get your questions answered. Quarter 4 ends May 21st. We're almost there. If you're happy with your grade on that day, then you're done. If you're not, you need to continue working for an additional week. So let's get these assignments handed in. Don't forget, if you have a 60% or better, you'll be eligible for remediation, and most of you can hit that mark just by handing in missing work. We'll be offering you 2 bonus point projects for the month of May. One project will be worth 10 points and will involve you choosing from a list of specific skills and creating a presentation of your choice on that skill. The second project will be worth 20 points. For this project, you'll create a presentation on systems of equations. We've designed these projects to be possible for every student to do and should be a boost to your grade if you make an effort to meet the requirements. You can get help in office hours, so there's not a good reason to not try these projects. Projects will be due by midnight on Friday, May 29th, and the expectations and rubric for these projects can be found on the Haiku page. Any struggles or celebrations today? I love hearing about what you guys are up to, so make sure that you let me know what your struggles or celebrations are this week. All right, we want to review being able to solve equations with variables on both sides. This is a skill that you'll need to be able to solve a system of equations correctly. So the first thing you want to notice is we have some like terms on this side. 2x take away 5x is negative 3x. And then I just bring down what I haven't used, which is the plus 7. And on the other side, there is nothing to simplify. These are not like terms and there are no parentheses. So first we're simplifying the things that are alike on each side. Now we want to look at like terms on opposite sides. Well, I noticed that I have an x on each side, so let's get those together. The opposite of a negative is a positive, so we do plus 3x plus 3x. What happens is the negative 3 and the positive 3 cancel out, leaving us just with the 7. You don't write the x because that means there's one x left, which there is not. Negative 3x plus positive 3x also cancels out, and you're left with 7 equals 8. 7 does not equal 8, and the variables all disappeared, so we say that our answer is no solution, which if we were in class, you could write that as this symbol. On your homework, you're going to need to write out in words that it's no solution. All right, pause the video. You try example 2 now on your own using the same type of steps. Welcome back. You should have noticed that you had 2 sides. You have like terms on the same side. 5x minus 7x is negative 2x, and we bring down the plus 8. On the other side, we have negative 2x minus 10. The opposite of a negative is a positive, so we're going to add 2x to each side. The negative 2x and the positive 2x both cancel out, and you're left with 8 equals negative 10. 8 does not equal negative 10, and the x's have all canceled out, so again, we say no solution. And if you were writing this out using pen and paper, you could write the 0 with a line through it. What if we throw in some parentheses here? So we want to distribute first. So 2 times 5x is 10x, 2 times negative 3 is negative 6, and we're going to bring down the other side. Now we want to check to see if there's any like terms. Over here there is not, so we just bring that down. But here there is. There is a 4x and a positive 6x, which make it 10x, and then we bring down the minus 6. I notice that my 2 sides are exactly the same. What that means is I can go ahead and say that these are infinite solutions, or you can use what I call laying down 8. If you wanted to go one step farther and get your like terms on the same side, we can do that, and then you can notice that, again, the 2 sides are exactly the same. All right, pause the video. You try example 4 on your own right now. You should have started by distributing, so 3 times negative 2x is negative 6x, and 3 times 3 is 9. On this side, we have some like terms. 1x minus 7x is negative 6x, and we bring down the plus 9. You could have stopped here once you notice the 2 sides are exactly the same, or you can go one more step. You can add 6x to each side. Those cancel out. Those cancel out. You're left with 9 equals 9, which again is infinite solutions or the laying down 8. All right, what is a system of equations? So we talked last time about a system of equations is just 2 or more equations with the same variables. So you've got 2 systems there, both of them have an x and a y. The solution to the system is the point where the 2 lines intersect, and the solution can be written as an ordered pair. You should have this information in your notes from last time, but if you don't, you're going to want to pause the video and write this down now. Again, this was in your notes from last time, so you don't need to write this all down again, but I just wanted to give you a quick reminder. Graphing is not the most convenient way to solve a system, especially if the numbers are large or you have decimals. It can be hard to find the intersection. But if you are needing to graph, then you're going to put both equations into slope-intercept form, graph the two lines, and find the intersection. So that takes care of graphing. Substitution is easiest to use when one of your variables is already isolated, like you maybe have y equals 2x plus 3, and then the other one is 2x plus 4y equals 8. One of your variables is already isolated, so substitution would be a good method there. And then here's your steps. Isolate one of your variables, substitute the expression for that variable into the other equation, solve, and then substitute back into either equation to find the other variable. You want to use elimination when one of your variables is not already isolated, like you have 2x plus 3y equals 7 and negative 3x plus 5y equals 8. Both those equations are in standard form, which makes this good for elimination. And then you would need to multiply if necessary to create opposite coefficients. For example, for this one, we would want to create like a positive 6x and a negative 6x by multiplying that top equation by 3. Then we're going to add to eliminate and solve. And then notice that step 4 on both of these is exactly the same. Your last step is to take whatever you got for the variable and substitute into either equation to find the other variable. Again, this was in your notes from last time, so you don't need to write all this down again unless you need to see it. All right, if you do not know how to use substitution and elimination, this is not going to be good times for you. You need to stop here, go back to Haiku, and redo the lessons on substitution and elimination. Then attend an office hour with me, and I can help you on that before we dive into special systems. So when we're looking at what can happen with systems of equations, there's 3 things that can happen. One is that your 2 lines intersect at one point. There is one solution, and we always write it as an ordered pair. You don't need to write down the words one solution. You just write what the solution is, like 3, 2, 5, 7. Sometimes, though, your lines do not intersect. If you have parallel lines, they're not going to intersect, which means there's no solution. So we write no solution or the 0 with the line through it, the phi. Or sometimes when we graph the 2 lines, they perfectly overlap, which means there are infinite solutions, and we write infinite or the laying down 8, just like we did on our work a while ago. Again, this same information was in your previous lesson, so this was just a review of that. So let's talk about what it looks like to get no solution. Notice that one of my variables is already isolated. In fact, 2 of them are. So I'm going to use substitution for this one, since one of my variables is already isolated. We take what's in that box and we put it in for y in the other equation. Again, it's like I'm taking out the dollar and replacing it with 4 quarters. And so I get something that looks like this. I've just replaced the y with negative 2x minus 5. Now I notice that I have like terms on opposite sides, so I'm going to add 2x to each side. The negative 2x and the positive 2x cancel out. I'm left with negative 5 equals 3. My solution is not negative 5. My solution is not 3. My solution is that there is no solution because there's no number that will make negative 5 equal to 3, and so we write a 0 with a line through it. When all your variables are eliminated and the 2 sides are not equal, then your solution is no solution. All right, you pause the video and try the next one on your own. Welcome back. You should have, again, used substitution for this one because y is already isolated. Y is equal to negative 3x minus 4. So I can just replace y in the other equation with negative 3x minus 4. So I've replaced y with negative 3x minus 4. I do that because now I have the same variable instead of 2 different variables. I'm going to add 3x to each side to get the like terms together. The negative 3x and the positive 3x cancel. I'm left with negative 4 equals 6. Which again, your x's have eliminated. Negative 4 does not equal to 6, so we say that there's no solution there. Now, what if we get infinite solutions? What does that look like? Again, I'm going to use substitution because one of my variables is already isolated, so I'm going to use substitution on this one. This one looks a little bit different, but I'm still replacing y in the other equation with whatever y is equal to. This is where we want to use our parentheses. So I'm replacing y with negative 3x minus 1, and I bring down the equals 2. I'm going to distribute first. The negative 6x just comes down. I'm not distributing it, and we want to treat this like a negative 2. So negative 2 times negative 3 is positive 6x. Negative 2 times negative 1 is positive 2, and that equals 2. We're going to combine our like terms that are on the same side. Negative 6x and positive 6x cancel out because they make 0. I'm left with 2 equals 2. 2 will always equal 2. The sides will always balance, so we say that our solutions is infinite solutions. And we can use the laying down 8 as a shortcut. So when all of our variables are eliminated and the two sides are equal, then your solution is infinite solutions. All right, pause the video, use this same process to try the next one now. Welcome back. You should have replaced y in the other equation with 2x minus 4, and use your parentheses when you do that so that you remember to distribute. We're going to distribute the negative 3. The 6x just comes down. Negative 3 times positive 2x is negative 6x. Negative 3 times negative 4 is positive 12. We're going to combine our like terms that are on the same side. 6x minus 6x makes 0, so we're left with 12 equals 12. All of your variables have eliminated. The two sides are equal, so the solution is infinite solutions. And we can use the laying down 8 there. Nice job. All right, time for the code word for today. The code word for today is going to be finals, because you didn't have to do any this week. So I know e-learning has been really hard and difficult, but if we were getting close to the end of the semester in regular school, you would have had to have prepared for all those tests all over again, and you didn't have to do those this time. So I would say for you guys, that's a bonus for this semester. So nice job. So finals are going to be your code word for today. All right, so sometimes we'll have to decide, is this no solution or infinite solutions? So I'm going to use substitution for this one because y has already been isolated. So I'm going to replace y with 5x plus 4. I'm going to use parentheses since I need to multiply by the negative 2 to substitute in the expression. I'm going to distribute. So we have 10x. 2 times 5x is negative 10x, and negative 2 times 4 is negative 8. 10x minus 10x is 0, so those cancel out. So let's think for a minute. Is this no solution or infinite solutions? The variable has eliminated, so it has to either be no solution or infinite solutions. Well, it's no solution because negative 8 does not equal 4. There's no way to make that one work. For this one, I'm going to use elimination because I do not have a variable that's isolated. So I notice that 2 and 6 have a common multiple of 6 because 2 times 3 would make 6. I also need these to be opposite signs. So instead of a positive, I need a negative here. So now I'm going to distribute that negative 3. That turns that into negative 6x plus 3y equals negative 12. The bottom equation is 6x minus 3y equals positive 12. And then I'm going to add. Negative 6x and positive 6x make 0. 3y and negative 3y make 0. I don't want to leave this empty over here because this is a scale. It needs to balance. So I'm going to write that equals 0. Negative 12 plus 12 equals 0. My solution is not 0. The variables have eliminated, so it either has to be no solution or infinite solutions. In this case, it's infinite because the two sides are exactly equal. All right, you try these on your own. All right, welcome back. I'm almost up to my 15-minute mark, so I am going to go ahead and just give you the answers for these real quickly without going through every step in the process. All right, so for the first one, I used elimination because I noticed that everything was already in standard form, and I already had opposite coefficients of negative 1 and positive 1, so I added straight down the columns. 0 does not equal negative 2, so we said no solution. I also used elimination for the second one because they were both in standard form, but this time I needed to multiply. I wanted a positive 2 and a negative 2, so I multiplied my top equation by 2, add down the columns. I got 0 equals 0, which is infinite solutions. All right, time for your IP. You only have 2 left, one today and one at the end of the week, plus the projects if you want to do it. You're going to go back to the Haiku page, use these notes and office hours if necessary to complete the IP. Putting IDK or leaving blanks too many times could cause you to fail. I'm here to help. Come to some office hours. Looking forward to seeing you guys. Bye-bye.